Happy Thursday, everybody. This is our second to last video, if you can believe it. On Tuesday will be our last video because the following Thursday, a week from today, we'll be reviewing. And then the last week we'll take our test and then have a review for the final. So we are really coming down to the end. I just wanted to throw this out at you. The OWOW that you currently have in Blackboard is not due for a week from today, because actually the material we're going to cover now is a huge part of it. So you don't have to give it to me until a week from today. All right. So just want to make that little plug again. And if you have your packet out, I added a few questions to it that I just wanted you to think about, little thinker questions. So in purple I wrote, it says we study the least common multiple. Why don't we study the greatest common multiple? That should be an M. Why don't we study the greatest common multiple? So I want you to pause and think about that. And then we study the greatest common factor. Why don't we study the least common factor? So see if you could just make little notes on the side, like pause the video, and see if you could just make a little note to figure those two questions out. So give it a pause and then tune back in. All right, we study the least common multiple. Why don't we study the greatest common multiple? Well, it doesn't exist. The greatest common multiple doesn't exist. That's why we don't study it, right? Numbers are infinite, so we'll have an infinite number of common multiples, and they just keep getting larger and larger and larger. So there was not a greatest common multiple, so we don't study that. And we study the greatest common factor. Why don't we study the least common factor? Well, it's not too exciting because the least common factor is always 1. So it's not really exciting. That's why we don't study it. All right. And the middle question, when do you think the least common multiple of two numbers is not greater than either number? I mean, all these ones we've been doing, the least common multiple has always been greater than the two numbers. Well, let me give you an example. Ready? Let's find the least common multiple of 6 and 12. So if you start listing the multiples of 6 and you start listing the multiples of 12, you're going to see very quickly what's going to happen. Do you see? The first multiple that's common is actually one of the numbers. So when you think the least common multiple of two numbers is not greater than the two numbers, well, it's when it's equal to one of the two numbers. So when one of the numbers is a multiple of the other, that's when the least common multiple is not greater than the two. And then the last little bit, these were actually out of Engage New York. These were some 6th grade questions that were some really cool applications of least common multiples. So let's just look at 2 of them. So how about this first one? It says, this is the great mystery of the world. Hot dogs come in packages of 10, but hot dog buns come packed in 8s. Don't know why that is. So if we want 1 hot dog for each bun on a picnic with none left over, what's the least amount of each we need to buy? This is a least common multiple question. So they're asking us to find the least common multiple of 8 and 10. So let's start listing some multiples of 8. Times 2 times 3 times 4 times 5 times 6. All right, let's start listing the multiples of 10. 10, 20, 30. Oh, there it is, right? So if we buy 40 of each, so then we'll have to buy 4 packs of hot dogs, right? 1 pack, 2 pack, oh wait a second. Oh, hot dogs come in packs of 10s. So 10, 20, 30, 40. So there's 4 packs of hot dogs. And for the buns, 1 pack, 2 pack, 3 packs, 4 packs, 5 packs. 5 packs of buns. So that is a least common multiple question. All right, here, let's try another one. Let's jump down to C. 2 gears in a machine are aligned by a mark drawn from the center of one gear to the center of the other. The first gear has 24 teeth. The second gear has 40 teeth. So it says, how many times do they have to go around until they are lined up again? So this is a least common multiple question. Let's try it. Let's do it. Let's do it a different way. Let's do it with like the exponent way, just so you have some practice with that. The Lickum method. So the Lickum method requires, right, that we find the factor, prime factorization of each number. So 24 is 2 cubed times 3. Okay, so you go ahead and find the prime factorization of 40. It's called the prime factorization because all the numbers are prime, and these are all factors. Did you guys get 2 cubed times 5? Okay, so the Lickum method means you want one of every flavor. So I want a 2, a 3, and a 5. And the most scoops we can get. So the highest power of 2 is 3. The highest power of 3 and 5 are both 1. Right? So 2 cubed times 3 times 5. Did you guys get 120? Man, I wish we were together. I miss seeing you guys. Did you get 120? All right. So that's the least common multiple. So how many times does the gear with the 24 teeth have to go around to get to 120? So how many 24s can we get out of 120? Okay, so this is going to have to do 5 revolutions. Okay. All right, and then the 40 teeth one, we have 120. How many 120? How many 40s can we get out of that? And that's 3. So the gear with the 40 teeth is going to make 3 revolutions. So that's kind of cool, right? I mean, that's 6th grade work. That's a cool application. I think those are cool. So those are basic applications for least common multiple. We're going to look at more when we add and subtract fractions. That's a big thing for least common multiples as well. All right. So the way that Engaged New York is explaining, one big way of explaining finding simplified fractions is with this prime factorization method, and I think it's cool. Most people are more comfy with multiplying than dividing. So what Engaged New York is doing is having kids make little factor trees and rewriting these numbers as the product of their primes. Okay. And then they know if you have the same number on the top as you do on the bottom, that equals 1, and those will reduce down to 1. And then the factors that you have left are the fraction that's in simplest form. Okay? It's interesting. All right. So to use the prime factorization strategy, we're going to break these numbers down into their product of primes. So 24 is 2 times 2 times 2 times 3. 40 I mean, you can just stop the video. I'm just doing my factor trees. So go ahead and stop it if you need to. So pause it, and then come back and join me after you've done your factor trees. And then try the next one too while it's paused. All right, so do you see then all of these 2's simplified down to 1, and what we have left is 3/5. So it's kind of a neat way to simplify fractions. I was always taught like you divide top and bottom by 2, and then you keep going. Then divide by 3 if it's a common factor. Like we were taught it with division. This is kind of cool. They break it down to its product of primes, and then they just cancel. All right, so pause the video if you haven't done this one yet. I'm going to do it right now. So it's all about learning these new strategies. Okay, so 42 is 2 times 3 times 7. 60 is 2 times 2 times 3 times 5. And then it looks like we can cancel a 2 and a 3. So we'll have 7 over 10 left. And here's the other thing. The numbers that you cancel, that's the greatest common factor. So 5's the greatest common factor between 10 and 20. 2 times 2 times 2 is 8. So 8's the greatest common factor that's common between 24 and 40. And it looks like 6 must be the greatest common factor, because that's what I canceled out, between 42 and 60. So finding simplified fractions, so fractions are simplified if the numerator and denominator only share a common factor of 1. Another way to simply put that is that they are relatively prime to each other. All right, and then the last little thing, and we've already done this, we've already talked about this. They say arrange these fractions from smallest to largest without converting these into equivalent fractions. All right, you don't want to draw pictures or anything like that. We just want to talk about how close they are to 1. My benchmark is going to be 1. So does everyone see these are 1 piece away from a whole? Right? So which one has the smaller missing piece? That would be the 5, 6. So 5, 6 is the largest. Oh, they went smallest largest. All right, so boop, 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 boop. I'll put the largest over here. 5, 6 is the largest. And now comparing these two, which one would be smaller? Well, they're each missing 1 piece, but this is the smaller piece. So 4/5 would be the next large. Oh, they're right in the right order. And then 3/4. Interesting. So they're each 1 piece away. A 1/6 is much smaller than a 1/5. So this value with the missing piece is closer to 1. And then you can use that explanation for the rest of them. It's that whole 1 piece missing concept. All right, so the only other thing that deals with this section is this supplement that I put. Is called, in section 2.2, it's a little bit more fraction work, and it deals with comparing pictures and getting oriented to what a whole is. And so I think that this is what is a big challenge for young adults and adult learners, that fractions can be a little confusing because the whole, or what represents a 1, can be different in different problems. So for example, if you have this hexagon, then the trapezoid equals a half. If the hexagon is a 1, then the trapezoid is 1/2. However, if this rhombus or this diamond is a 1, then the triangle equals a half. That's weird, right? I think that's unusual for us to wrap our brain around a little bit. So for example, if 2 squares equals 1, then 1 square equals a half. But if 2, 4, 6 squares equals 1, then 3 squares equals 1/2. This is odd, because this is even bigger than the whole that we started with in the previous problem. Right? So it can be a little bit confusing. And they talk about geoboards. So geoboards, I think we've talked about it in a class before. These have the little nails, and these are rubber bands. So if this is equal to 1, then you can pick up the rubber band and put it on the next set of nails. So that would be a half. So this is the 1, and this is what the 1/2 would be. And if this square was equal to the 1 on the geoboard, then this rectangle would be the 1/2. It's just a matter of moving rubber bands around. So that's what gets a little confusing. And that's why I made a lot of these on the OWL, so they're forcing you to kind of think about them a little bit. All right, so let's practice. So why don't you pause the video and see if you can make some sense out of that first set of questions. It says arrange each of the following questions, or answer each of the following questions by sketching your solution. So if you'll notice, each question tells you what the 1 looks like, and then they ask you to draw something from there, okay? So why don't you pause the video and see if you can make some sense of it. All right, so let's look at all of these. So they say, so if your picture equals 1, do you notice that all 4 of these we were given 1, and then we're trying to sketch A over B. All right, so the first thing you need to realize, if you are going to sketch 2 pieces out of 3, 3 is the number of pieces that make up the whole. So 3 pieces make up the 1. So we're going to have to break these down into 3 pieces, and then we only want to sketch 2 of them. So I can either go this way or up and down, but we want to break this down into 3 pieces. So my 1 is now broken up into 3 pieces, and I want 2 of them. So that's what 2/3 would look like, what I have shaded in there. All right, let's try this one. So we're going to sketch this, we're going to break this down into the denominator equal parts, and then we're going to sketch the numerator. So I broke this down into 3 equal parts, and then we want 2 of them. Now this one's a little more unusual, so we want to break this down into 3 equal parts. This is an unusual question, and usually we have manipulatives that we can play with, so unfortunately we can't, because mine are all in my office and they won't let me go back. So when you have these hexagons, you can break them down into trapezoids, and then each trapezoid has 3 triangles in it. Does that make sense? So there are 12 triangles. So as odd as it is to think about, 4 triangles represents a part. Ready? I'm going to color it in so you can see it. There's 1 part. There's 2 parts. And then I'll color in these green. So do you see I broke those 2 trapezoids down into 3 equal parts. So we want 2 of them. So I would want, let's see, I would want 2 parts. So I would want from here over something like that. Everything but the green. So if your picture equals 1, then to sketch A over B, we need to divide the picture into B equal parts. Whatever the denominator is, we need to divide that up into that many equal parts. Then shade in A parts. the numerator. Does that make sense? Now, they could have said shade in, instead of 2/3, they could have said shade in 4/3. And so then we would have to have taken our 3 equal parts, and then we would have had to have shaded in 4 of them. So we would have had to have drawn an extra part. Okay? Hoping that makes some sense. So I would definitely take these notes for when you're doing those OLs. All right, and let's try these ones. Now the difference between these ones and these ones is that for these problems, you're not given the 1. You're asked to draw what 1 would look like. All right, so they're definitely a different type of question. All right, so you could pause it and just give it a try. We're going to do it together, but if you want to give it a try first, you could pause the video now and see if you can make something of them. All right, you ready? I don't know if you paused or not, but I'm going for it. So with these problems, you're not given what 1 looks like. So it's absolutely the opposite of the ones we just did. So for these ones, they're telling you that they drew 3 out of 4 parts. So you need to divide this up into the numerator equal parts. And then the denominator tells you how many parts you need to get to be a 1. So that's 3 out of 4, so 1 would be 4 out of 4. So we're going to add a part. If they said, for example, they said the trapezoid equals 3/5, then we would say, okay, well, we've got 3 out of 5 parts, and now we have to add 2 more triangles. And that's what 3/5 would look like, because we need 5 parts to get to 1. All right, so if this equals 3/4, we need to divide this up into 3 equal parts. 5, 6, 7, 8, 9. So each 3 squares equals a part. So this is 1 part, 2 parts, 3 parts. So to sketch 1, we need another part. So we need another 3 squares. So I'm just going to come over here and ram over that if. Okay, so I'm going to add that, and that's what 1's going to be. So for this rectangle, this is 3 parts out of 4. So then to make it 4 out of 4 parts, I'm going to stretch my rubber band over 1. So this whole rectangle would be 1. All right, I hope that makes sense. Okay, these are the same things, but you know what? The 1 and 1/3 we need to write as an improper fraction. So the way that Engaged New York does it, oops, 1 and 1/3. You remember they do their number bonds and say 1 is 3/3 and 1/3, so that's going to be 4/3. Remember, they love their number bonds. So first thing, you really have to figure out what the improper fraction is. So this is 4/3. This is equal to 4/3. So we need to draw 4 equal parts. There it is. And the denominator tells you how many parts equals 1. So I need to shade in 3 of them. And that's what 1 looks like now. So this is equal to 4/3. So I have to divide this up into 4 equal parts. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'm going to divide this up into 4 equal parts. Each part's going to be worth 4 squares. Okay, there's 1 part, 2 parts, 3 parts, 4 parts, and we want 3 of them. So there's 1 part, 2 parts, 3 parts. There you go. So that's what 1 looks like. See, they gave us too much, so we're not going to shade. We're not going to shade too much, right? We're going to shade less. And this is equal to 4/3. So we've got to break it down into 4 equal parts. And then the denominator says you only need 3 of them to get to what a 1 looks like. So that's what a 1's going to look like. So if your picture is A over B, then to sketch 1, we need to divide the picture into A parts. Then sketch B of these A parts to get to 1. Remember, the denominator here, I'm going to write this down. Remember, the denominator tells you how many parts equals a whole. Or equals a 1. Same thing. Okay? All right, and then the last little bit is a whole section that says understanding discrete models. And this should make sense that they call these discrete models, right? Because they're countable. Like this would be a continuous model. There's no holes or breaks in between the parts. But discrete models, remember, there's holes. We can physically count them, count the little pieces. So it should make sense why our book calls those discrete models. So you should have enough background that you can conquer this. Why don't you pause the video, give it a little pause, and see if you can make sense of those. Okay? Give them a pause, look back at the 2 types of problems, and see what you can make of it. All right, so let's see. So if we are asked to find 1, then we're going to come up here. This is the directions. So divide the picture into the numerator equal parts. So they're giving us 2 parts out of 3. And we want 3 parts to equal 1. So I'm going to add another 3 dots. So that's what 1 looks like. 9 dots equals 1. All right, let's try this guy. If the given diagram has a value of 1, okay, so now it's equal to 1. So now these are these directions. So divide the picture into the denominator equal parts. So we want to divide this into 4 equal parts and only take 3 of them. All right, so we're going to divide this into 4 equal parts. So 1 has been divided up into 4 equal parts. So we want 3 of them. So does it make sense? We want 6 dots. All right. So remember, we have to convert this to an improper fraction. So 2 2/3. So Engaged New York would say it's 2/3. And then we've got to think in terms of 3. So 1 would be 3. 2 would be another 3 over 3. So we have 6, 7, 8/3. So this is 8/3. All right, so we're going to come up here. So divide the picture into the numerator equal parts, and then we want 3 of those parts to get to 1. Okay, so we have to divide this up into 8 equal parts. So 1, 2, 3, 4, 5, 6, 7, 8. So this is 8/3. And to show 1, we want 3 of these. So 2, 4, 6. So again, it would be 6 dots. Does that make sense? Divide it, so if you're trying to find 1, you divide the picture up into the numerator equal parts, and then you just want the denominator number of parts. And I thought this one was interesting. So this is what 1/3 was. This is what 1/3 is. Okay, so if your picture is A over B, then divide the picture into A parts. So we're going to divide this into one part. So there's one part. So let's figure out what 1 is, and then we'll just take half of it. So there's one part. We want to then, so divide the picture into A parts, then sketch B. So we need to sketch 3 of these parts. There's 2/3, and there's 3/3. Alright, so if 12 dots equals 1, then 6 dots equals 1/2. How'd you do? Did you guys do okay? Does that kind of make sense? That, oh wow, tends to be a little challenging, but if you can just remember it's only one of 2 possibilities, it hopefully won't be too terrible for you, okay? Hopefully it won't be too bad. All right, the other little very short section, because we've done all of the work on it, is adding and subtracting fractions or rational numbers. Of course, we don't have the manipulatives, so let's just see what Engage New York has kids do. It's very short because this section is where we talk about, they talk about finding the least common multiple and what that is, and we've already covered that. So the only thing I want to do for this section is make it super short and super sweet, is just to remind you how to add and subtract fractions. And you need the least common multiple. And it's really cool to do this with manipulatives. So again, with my kids, they had these little Ziploc baggies of colored circles, and it was nice for them to see that like 1/2 was different than 1/3. 1/2, like I think it was bright pink. The 1/2 semicircle was bigger, first of all, than the 1/3. I wanted to say that was orange, but there was no way to add those together. You needed to find a unified color that they all had in common, and that's what this LCM is. All right, so let's just look at some examples that Engage New York gives us. So they wanted to add 7/10 plus 3/5. So you can see here that they found a common denominator of 10, which was the first common multiple these had in common. And then they wrote an equivalent fraction. I love this. So then they kept the denominator and added the numerators. And then do you see their technique with the number bonds to go back from an improper fraction to a mixed number? Thought I'd throw that at you so that you guys see that they use it all the time with Engage New York. Right? So 2/3 plus 5/6. So you can see here that they divided everything up into sixths. So 2/3 plus, over here, I'm like, where is it? Plus 5/6 equals 9/6. So here's their fractions where they found their common denominator. You keep the denominator, add the numerators, and then they wanted them to convert this to a mixed number. So they say draw a model if needed. What do you think? Here they're just finding the equivalent fraction. So here, let's just try this. Now this one's kind of goes along with this. Here, we'll try this one first. So the least common multiple, the first multiple they have in common is 6. Right? So we need to convert this to a denominator of 6. So if I multiply top and bottom by 2, that's going to give us 4/6. So we're going to add 4/6 plus 5/6. Right? That's going to give us 9/6. And so Engage New York would say that 6/6 plus 3/6. Oh, it's this one right here. I'm like, this sounds so familiar. Which would be 1 3/6. Now, they're not having the kids reduce that yet. Do you see in the answer key that that's not reduced? I mean, we know it's 1 1/2, but anyway, this is a little bit harder checking out all these because the common, all it looks like the LCM is all a multiple of the other ones. So I'm hoping you would see that, like, what I might repeat that. All of these problems, the least common multiple is one of the two numbers. Do you see that? So 6 and 2, the least common multiple is 6. 10 and 5, the least common multiple is 10. That's not the case for this one. So the least common multiple, I'm hoping you guys would recognize, is 15. All right. So we're going to convert both of these so that the denominator is 15. So to make equivalent fractions, right, you have to multiply the numerator and the denominator by the same number. And then the key thing is, which a lot of my adult learners forget, is that you add the numerators and keep the denominator. You got to keep it. All right? And then here, let's just practice the Engage New York way. To convert that to a mixed number, they would say it's 15 over 15. All right, and then 7 over 15 left. Cross that off and call it the 1. So they have 1 and 7 over 15. All right? All right, so I'm hoping that that makes sense. We don't really need to figure out how to find the least common multiple because we've done that quite a bit already, and that's introduced in this section as well. And then the one thing I want to talk about with fractions, and of course we don't have manipulatives, but we'll work it out anyway. Subtraction of fractions can be a little bit more complicated, even with the common denominator, because sometimes you can't take away 4/5 from that 2/5. So what Engage New York does is, they love their number bonds, they're going to call that 5/5 and 2/5 and say that this is 7/5 minus 4/5. And now you can say, okay, well, if we take 4 away from the 7, that's going to be 3/5. No problem. Right? No problem. So this, same with this. You could write it vertically. I was always taught to write it vertically, but it helps students to see the fractions written in expanded form. So if we write this as 22 plus 1 and 2/5 minus 17 and 4/5, do you see what I did? So I just, 22 plus 1 is 23 and 2/5, and then we're going to do what we did upstairs. So we'll have 22, and then this is going to be 5 over 5 plus 2/5. This will be 22 and 7/5 minus 17 and 4/5. So now the kids can see, well, we can take 17 from 22, that'll be 5. And then we can take 4/5 from 7/5, and that'll be 3/5. No problem. All right, so that's it for just adding and subtracting fractions. That should be fairly easy, especially because we know how to find the common denominators because we've already done that with the least common multiples. So we have one section left. It'll be posted. It's section 4-3, multiplying and dividing fractions. That will be Tuesday's lesson, and then there'll be a huge celebration because you guys survived. You survived this crazy way to have to learn virtually. So I'm glad you stuck with it, and let me know if you have any questions. Feel free to Zoom anytime, and I will hopefully see you soon. Have a good weekend and get that last oh wow done. All right, take care everyone.